Here we go. We have a question, longest 9 subarray. So you are given an integer array consisting of positive integers. We call a subarray of nums nice if the bitwise AND of every pair of elements that are in different positions in the subarray is equal to 0. We need to return the length of the longest nice subarray. A subarray is contiguous part of an array. We already know this. One note here is that the subarray of length 1 are always considered nice. So we have given this array, and in this array, as we already know, there are many subarrays, but we want to find the longest nice subarray. And what is the definition of nice subarray? It is the nice subarray if the bitwise AND of every pair of elements is equal to 0. So bitwise AND means bitwise AND of every pair means so I hope you already know what a AND function, what a AND bitwise operation does. So it check that whenever there are two set position, it will give me set, but if one of them is unset, it will give me 0, right? So this is the longest nice subarray 3, 8 and 48. In this, none of the bit occurrence on any given position is greater than 1, right? So this is the subarray, and bitwise AND of every pair in this subarray is equal to 0. So this is the length is 3, and in this the length is 1. So I hope you got this question. So let's build the approach. So suppose I have given this string, and we want to find out what is the longest nice subarray. So we have 1, 3, 8, 48 and 10. What is the answer? The answer is 3, 8 and 48. So let me quickly write the bitwise for 3, 8 and 48. So here I have written the bitwise AND of 3, 8 and 48. So if I do the AND operation between any of these three pairs, it will give me resultant as 0, right? So 3 and 8 is 0, 3 and 48 is 0, 8 and 48 is 0, right? So as you can see, bitwise AND on any given position, the occurrence is no more than 1. The occurrence is no more than 1, right? Yes. So we need to figure out the longest subarray, right? So if I include 10, what if I include 10? What is 10? So 1, 2, 4, 8. So it will look like this. So if I include this, so bitwise AND of 3 and 10 is equal to the bitwise AND on this position is greater than 1, right? So we cannot take 10. So we need to make sure that the array in the range of L to R is the bitwise on any given position is no more than 1, right? So you can take a bits array of 32 size, so you can take this, but we can also take a single value. So let me solve this question using a single value. How we can solve this question? So first let's take a value as 0. So we have 0. So we're gonna apply sliding window obviously in this question. So first we have this, and what is our value? Our value is initially 0, and if I do AND with 1, so bitwise AND of 0 is this, bitwise AND of 1 is this, so it will give me 0 and 1, right? And we can take this number, right? So I got this number as 1, right? So now let's extend our window. We got this window. So we already have value as 1, and if I take if I take 3, so it will look like this, and it will give me what it will give me, it will give me this. And here I am doing AND operation, I am applying AND operation, so it will give me this, which is greater than 0. What it means, so what it means, we have two values whose this position is set, whose this position is set. So we don't want two values, we only want one value, right? So we only want one value. So what we gonna do, we gonna compress our window. So uh, we cannot take this element, we cannot take this element, but can we compress the window and find our actual length? So let's find it. So we are removing the value from this array, okay, from this separate variable. So we are removing a value. So how we gonna remove it? How we gonna remove it? So let's check. If a value is given as this, which is 1 only, and I want to remove 1, I want to remove 1 from this, but I cannot apply subtraction here, I have to play on bits. So if I play on bits and I want to unset this bit, how we gonna unset this bit? We gonna apply XOR operation, and I can just unset the set bits or set the unset bits, right? So on the same thing it will give me 0, so my value becomes 0, my value becomes 0. Now can I take the value 3? Can I take the value 3? So I am getting 0, and I have this value. So can I take this value? How? What it means is, can I apply XOR here? It means I am taking this value, I have to check, I have to check. So not and, I have to apply AND. It means I am checking, is this number greater than 1? Is this number greater than 1? No, this number is not greater than 1. It means I can take the value 3. I can take the value 3. Right? The value, the bits on any given position is no more than 0. Right? So I can take the value 3. How we gonna take the value 3? If my value is 0, how we gonna add or take 3 in this case? So 3 is this, we can apply OR operation, and it will give me 1 1. It means my resultant is 3 now. I have just taken this number. Now let's go ahead and take more elements. My current value is 3 only, and my new element, this is 3, my new element is 8. So what is 8? So it is this 1 2 4 and 8, right? So I need to check, is there a position, is there a bit position on which I am getting a bit as set in both of the cases? In both of the cases means I have to check for AND operation. Is I am getting bit set on both of the places? No. No. The bits are different. It means we can take this number. How we gonna take this number? So this is to check, and to take a number. This is value. Already value is 3. Now I can take this number. I can apply OR operation. So it will add up, it will add up, and it will give me 8 plus 3 11. It will give me this 11. So I am not considering the value, I am just accessing the positions. So I have 11 here. So we have this window. What is the window size? On every step we also need to consider the maximum window size, right? We also need to consider maximum window size. My window size is 2. Yes. So let's add more bits here. My value is 11 currently. My current value is 11 and 11 can be written as this. The next value is 48, which is 1 1 and 4 times 0, which is 4 times 0, then 1 1, right? So 48. Is there a position on which both of the bits are set? Is there a position on which both of the values, both of the elements are set? No, there is no position. So this is to check. If there is a position, we need to compress it, and we need to remove 3, we need to remove 8, we need to remove 48, but there is not a single value in this case, but there will surely be a value in the next iteration. So in this case there is no element. Now is to consider it, is to add up. So we have 11 here, we have 45 here. 11 is like this, 45 is like this, and to add up, to sum up the bits, to sum up the values, what we got? We got this, 0, this. So what is the summation here? 1, 2, 4, 8, 16, then 32. Right? So which is equal to 64 minus 4. 64 minus 4, which is 60. So I think we got 60, and this is a valid window. I have L and R representing the left side and the right side. I think we got 60, if I'm not wrong, right? So we got this. So let me verify this. So it is not 69, it is 59, which is 111011, and my window length is 3, right? So we need to consider more elements, right? So my current value is 59, which is like this, and my next value is 10. 1 2 4 8, so which is this, which is 10. So is there a position on which, is there a bit position on which both of these bits, both of the elements are set? So this is to check. We gonna apply AND here. Yes, there is surely a bit. It means it is greater than 0, right? It is greater than 0. So we need to compress it. We gonna need to subtract some elements. So it will give me surety. So we need to remove some elements. So let's do this. So we have currently 1 1 1 0 1 1, right? So now I am removing 3. What is 3? 3 is this. How we gonna remove it? We gonna apply AND here. So on the set bits it will unset it, and we got this. So it will give me 56, and my window length is this only. I got 56. I got 56. So my this bits is unset. Now again check, can I take 10 now? Can I take 10? 1 1 1 0 0. This is my 56, which is already a number. Can I take 10 now? What is 10? This is 3 times 0, so which is 10 is like this. Is there a set bit on any given position? How are we gonna check? We're gonna apply AND. 0 0 1 0 0 0. Yes, it is greater than 0. It means there is still a value present. In this case we cannot apply AND. We cannot take 10. We cannot take 10. Now this time we need to remove 8. How are we gonna remove 8? How are we gonna remove 8? So on this number I am removing 8, which is which is 8 is like 1 0 0 0, and I want to unset this bit. To change the bits, we need to apply OR. So this is 1 1 0 1 uh, 0 0 0. So which will give me which will unset this bit only, and 1 0 0 0, right? Then I'm subtracting 8. Now this number is 48. Can I take 10 now? Let's check. So this number is already we have, and 10 is written like this. Can I take this number? If I do the XOR, we are getting 0. This number is not greater than 0. We can take 10. Yes, we can take 10. So how to take 10? If I do the AND operation here, it will give me the resultant, which is the set bits. Yes, now the number is 58, and this bits is also set, this and this bit. So it will look like 1 0 1 0, and my number is 58. What is the window length? Window length is 2 only, which is less. My length is more, the length 3 is more. So that's how this will work. And now we don't have any more elements. This is the largest window length, and that's how this will work. It will purely based on sliding window and bit operations. So let's code this. So we need a value, we need n, we need L and R, but L and R can be written inside this, right? So I am while value and nums of r, if this number is greater than 0, it means that bit is already set. We can that bit there is some bit that is already set in my previous window. Now I cannot take nums of r. I first have to remove some values till all the bits that are set in this are unset in this. So to unset or change the bits, we gonna add this, right? So my value is getting updated. If there is set bits, it will get unset. If there is unset bits, it will get set. Now I need to consider the rth number. I still have not considered the rth number. This is to just verify, just set the unset bits. Now the next step is to consider nums of r. So now I have considered nums of r, and that's it. That's enough. But I also need to find the maximum window length. Math.maximum r minus l plus 1, which is the window length, and I have not defined my answer. Let's return the answer here. Let's run this, and we also need answer here. And working fine. Let's submit this and accepted. So we have solved this question, and one thing that this is purely based on bits, but you can apply minus here as we are subtracting it, and to consider it we can apply plus here. Now let's run this and check if this work or not. Yes, this is working, and let's submit this if this work or not. It should work. Yes, it is working. Now let's discuss about the time and space complexity. The time complexity in this case, this is simply a sliding window. The time complexity will be order of n. Space in our case is constant. That's all. Thank you all for watching.